Hello there, athletes. Welcome back to Math Jamboree. In this video, we have another APP calculus type of a question from the topic of equivalent representations of polynomial and rational expressions. Let's solve it together. Let f be a rational function. The denominator of f has a 0 at x equals 2, and the denominator has x zeros at x equals 2 and the x equals 5. The multiplicity of x equals 2 is the same in both the numerator and denominator. What is true about the graph of f? The graph has holes at 2 and 5. B, the graph has a vertical asymptote at 2 and a hole at 5. C, the graph has a hole at x equals 2 and a vertical asymptote at 5. So the graph has a vertical asymptote at x equals 2 and 5. So what does this mean? In this question, I want you to just have a better understanding of this type of questions. To do that, we're going to just focus on the question translating these words into mathematical expressions. So we're talking about f of x. They're saying that we have in the numerator, zeros at 2 means x minus 2 you must have. And denominator has zeros at x, so same thing, and x minus 2, right? And x equals 5 in the denominator, so x minus 5 will be in the denominator. Multiplicity of, they indicated this, so there is x minus 2 and x minus 2 in numerator and denominator, which is a whole, right? If you're canceling this out, there is a whole at 2. And what else? There is a vertical asymptote because x minus 5 equals 0. When you make it and solve it for x equals 5 is the vertical asymptote. So in this case, so the graph has a hole at x equals 2 and 5. No, it has only one hole. So the graph has a vertical asymptote at x equals 2 and hole at 5. It's vice versa actually. The graph has a hole at x equals 2 and the vertical asymptote at x equals 5 fits with our analysis. The graph has vertical asymptote at x 2 and 5 is not correct. So the correct answer is C for the specific question. I hope you found this video helpful. If you did, please give it a thumbs up. If you have questions or comments, you can always leave it below there. Thank you. See you next time. Bye-bye.